Hello students, welcome. Previously, Form 4, Topic 4, Lesson 1, we were dealing with the introduction side of electrochemistry. We said electrochemistry mainly deals with three areas. The first one was redox reaction. The second was electrochemical cells. The third one was electrolysis of non-binary electrolytes. So today, lesson 2, we are going to do oxidation numbers. So let us start by first of all defining what oxidation number is. So an oxidation number is the apparent judge that an element has in a compound or the judge on an ion. Okay, thereafter we have rules of assigning oxidation numbers. The first rule, we're told rule number 1, all atoms and molecules of elements have oxidation number 0. E.g., we can have atoms like sodium, its oxidation number is 0. Or we can have elements which exist in a molecular form like oxygen molecule, chlorine molecule, nitrogen molecule, bromine molecule, and hydrogen molecule. So their oxidation number, all of them is 0 because we are told all atoms and molecules of elements, not molecules of compounds. We are talking about molecules of elements like chlorine molecule have oxidation number 0. That's the first rule. Rule number 2, we are told the charge on an ion containing one element is equal to the oxidation number of that element. And we are told oxidation number is written with the plus or minus sign in front. Or in other words, we are told when writing oxidation number, the sign comes first before the number. E.g., we are having ion of magnesium, oxide ion or oxygen ion, we have nitride ion, sulfide ion, hydrogen ion, we have chloride ion, we have aluminum ion, and also potassium ion. So the oxidation number will be just equal to the oxidation number or the charge on the ion. So here we have plus 2 or 2 plus, that means the oxidation number will be plus 2. Here we have 2 minus, so it will be minus 2. Here we have 3 minus, it will be minus 3. And so on and so forth. Rule number 3. So in rule number 3, we are told the oxidation number of hydrogen in all compounds that contain it is plus 1, except in metal hydrides, where it is negative 1. What are metal hydrides? Metal hydrides are when metal reacts with hydrogen. The product or the compound that we are going to get is a metal hydride. So where it is oxidation number is negative 1. Okay, example or e.g., we're having the compound like hydrochloric acid. The oxidation number of hydrogen in hydrochloric acid is positive 1 because we are told the oxidation number of hydrogen in all compounds that contain is positive 1. So water is also a compound of hydrogen. We are having positive 1, hydrogen fluoride positive 1, sulfuric acid, the oxidation number of hydrogen is positive 1. But when we are dealing with sodium hydride, magnesium hydride, potassium hydride, it is negative 1 because that is metal hydride. Okay, here we have hydrogen iodide, the oxidation number of hydrogen is positive 1. So rule number 4, we are told the oxidation number of oxygen in all compounds that contain it is negative 2, except in peroxides, where it is negative 1. Okay, and oxygen fluoride, OF2, where it is positive 2. E.g., we have the compound here and the oxidation number of oxygen in that compound. Cobalt 2 oxide, the oxidation number of oxygen is negative 2. Water contains oxygen, its oxidation number is negative 2. But when we have oxygen fluoride, here oxygen will be having an oxidation number of positive 2 because here we are having in the exception side, except in peroxides where it is negative 1, like sodium peroxide and also that side of hydrogen peroxide. We have here hydrogen peroxide, it's negative 1, and we have sodium peroxide here, it's negative 1. Because we are told except in peroxide where it's negative 1. And OF2, that's oxygen fluoride, where it is positive 2. So this is oxygen fluoride, it is positive 2. So this is potassium oxide. So potassium oxide, the oxidation number of oxygen in potassium oxide will be negative 2, just like CO2 oxide, that side of water, and that side of nitrogen peroxide. Okay, next, rule number 5. Rule number 5, we are saying in compounds, the sum of the oxidation number of all constituent atoms is equal to 0. E.g., we have the compound here, an oxidation number. So sodium chloride, the oxidation number of this compound is 0. How? Because when we take the oxidation number of all the constituent atoms and we add them, they are going to sum up to 0. So for example, sodium chloride, it is having sodium, which is having an oxidation number of positive 1, plus it's having chloride. Remember, this sodium and this chloride are not neutral atoms. They are in a compound. So we are not going to say that sodium is having an oxidation number of 0 because it's an atom. No. So plus the oxidation number of chloride or chlorine is negative 1. So when you put this one in the calculator, you will get 0. We go water. So water contains 2 of hydrogen and the oxidation number of hydrogen is positive 1. Plus here we have oxygen. Remember, the oxidation number of oxygen is negative 2. So if you take this one, you put it in the calculator, you will get 0. So here we have sodium peroxide. So it has 2 of sodium, which its oxidation number is positive 1, plus 2 of oxygen. But remember, this oxygen is in peroxides. Remember, we said that rule number 4, the oxidation number of oxygen in all compound that contain is negative 2, except in peroxides, where it is negative 1. So if you put this one in the calculator, you will get 0. Then lastly, we have sodium hydride. So here we're having sodium and hydrogen. Remember, sodium is having an oxidation number of positive 1, plus hydrogen in metal hydrides is having an oxidation number of negative 1. When you take positive 1 plus minus 1, we are going to get the 0. We are going to get 0 as the oxidation number. In rule number 6, we are saying in ions containing more than one element, the overall charge is equal to the sum of the oxidation numbers of the constituent elements. E.g., we have the ion here and the oxidation number. So we have ammonium ion. So ammonium ion is having positive 1 there as the charge. So the oxidation number will be equal to, what is the oxidation number of nitrogen in compounds? So it's negative 3. How do you know it? You will know it that by just knowing the electronic configuration of nitrogen or the atomic number. Then thereafter you get the electronic configuration, then you get the valency. So it's non-metal, you will give negative. So the valency of nitrogen is 3. Plus, I have 4 here in bracket. What is the oxidation number of hydrogen? It's positive 1. So put negative 3 plus 4 in bracket plus 1. Close the bracket, put in the calculator, you are going to get positive 1. So that positive 1, it is the charge, the overall charge of that ion, that's ammonium ion. We get sulfate ion. So we are going to start by seeing first of all the oxidation number of sulfur in sulfate, it's positive 6, plus we are having 4 of oxygen, which its oxidation number is negative 2. When you put this one in the calculator, you are going to get negative 2, which is the overall charge of this ion. So here we have phosphonium ion. You have phosphorus here. The oxidation number of phosphorus is negative 3 because its valence is 3. Then we are having negative because phosphorus is non-metal. Then we put plus 4 of hydrogen, which its oxidation number is positive 1. When we put this one, we are going to get positive 1 there as the overall charge. So here we have hydroxide ion. So here we have oxygen, which it is oxidation number is negative 2, plus hydrogen, which is positive 1 also. When we put this one, we are going to get negative 1 as our overall oxidation number, which is here, the charge. Next, we are told, note, when the oxidation number of an element in a compound or in ion is not known, it is calculated from those of others by using rule number 5 and also 6 respectively. Examples. Number 1, we are told determine the oxidation number of iron in iron oxide, and the formula for that iron oxide is Fe2O3. So this is a compound. So that means that we are told the oxidation number of a compound is 0. So we are going to start first of all by writing first of all the compound Fe2O3 will be equal to 0. So here we don't know the oxidation number of iron because it's the one that we are calculating. So we are going to say 2Fe plus we have 3 of oxygen. So what is the oxidation number of oxygen? It is -2, close bracket. This will be equal to 0. So we are going to say next 2 of Fe, then remove the bracket, we are going to get -6. This will be equal to 0. So next we are going to have 2 Fe will be equal to, then we take that 6 to the other side, it becomes +6. So if we want to get Fe, that's iron, we are going to divide here by 2, then we divide here by 2. So what will be the oxidation number of iron now? So that means Fe will be equal to +3. So the name of this compound was iron 3 oxide, because the oxidation number of iron in that compound was +3. So question number 2. We are told what is the oxidation number of sulfur in sulfuric 6 acid? I mean in sulfuric acid. So how have they written the sulfuric acid? H2SO4. This is a compound. So we are going to write first of all the compound. And the oxidation number of a compound is 0. So we know the oxidation number of hydrogen. So let's write first of all 2 in bracket. The oxidation number of hydrogen is +1 in all compounds except in that side of metal hydride. So this is not metal hydride. Oxidation number of hydrogen is +1. Plus, then we are going to have sulfur, because we are told what is the oxidation number of sulfur. We don't know. We put S alone. Plus 4 of oxygen. The oxidation number of oxygen is -2. This will be equal to 0. So remove the bracket. We are going to have +2 here. Plus sulfur -8 will be equal to 0. That's what we are going to get. Then next, we are going to say collect the like terms together. We are going to have S plus 2 minus 8 will be equal to 0. So that means S minus 6 will be equal to 0. So if you want to get S, it will be equal to, we take that -6 to the side, it will become now +6. So the oxidation number of sulfur in this sulfuric acid, which is written H2SO4, is 6. So this one will be read as sulfuric 6 acid. Example 3, we are told determine the oxidation numbers of the atoms in the bracket. So we are given MnO4 negative. Then we are supposed to get the oxidation number of Mn. Okay, so we are going to say this is an ion. So that means MnO4 will be equal to -1, because we have the charge. In the last rule, we said in ions containing more than one element, the overall charge is equal to the sum of the oxidation numbers of the constituent elements. So the overall charge here is -1. So we don't know the oxidation number of Mn plus we have 4 of oxygen. We know the oxidation number of oxygen is -2. We close the bracket. There will give us -1. So let us remove the bracket. Mn minus 8 will be equal to -1. So thereafter, we are going to collect the like terms. We are going to say Mn will be equal to -1. Then we take -8 on the other side. It becomes +8. So Mn, we are going to get +7. So the oxidation number of manganese in this ion was +7. So this is manganese 7 ion. Manganese 7 ions, I mean. So but B, we are having that ion. So we are going to say this, we are going to write the same, or we are going to do the same. We are going to have Cr2O7 will be equal to -2. Because here we have -2, the charge, the overall charge. So we are told to look for that oxidation number of Cr. So we are going to say 2 of Cr plus 7 in bracket. What is the oxidation number of oxygen? It's -2. Close the bracket. This will give us -2. So we are going to have 2 Cr minus 14 will be equal to -2. So collect the like terms together. 2 of Cr will be equal to -2 positive plus 14. We have taken this negative cross to the other side. It becomes positive. So thereafter, we are going to have 2 Cr which will be equal to positive 12. So divided by 2, divided by 2. So Cr here will be equal to positive 6. That will be chromate 6 ions. So, but C, in the same question, the oxidation number of S, that means the oxidation number of sulfur in this sulfite ion. So we're going to say SO3 will be equal to negative 2. We don't know the oxidation number of sulfur because it's the one that we are told to look for. Plus 3 in bracket, the oxidation number of oxygen is negative 2, close the bracket, will be equal to negative 2. So we're going to remove the bracket, S minus 6 will be equal to negative 2. So that means next step we are going to say S will be equal to negative 2 plus 6. Then S will be equal to positive 4. So this one was known as sulfate 4 ions or sulfite ions. Thereafter, we are going to go to uses of oxidation numbers. The first use of oxidation number is it determines whether a reaction is a redox or not a redox reaction. Example, we are told with the reason, state whether the reaction below is a redox reaction or not. So we are having calcium hydroxide solution plus hydrochloric acid solution. We are going to get calcium chloride solution and also water. So this reaction is a neutralization reaction. Remember, we were having examples of redox reactions. There were 3. One was the reaction between a metal and dilute acid. Number 2, metal and also water. Number 3, displacement reaction. And we were having note in our previous class where we have said neutralization reactions and precipitation reactions are not redox reaction. And the reason being that because they are not accompanied by changes in oxidation numbers. So in our case, if we check the oxidation number of calcium here is positive 2 and also here is positive 2. So there's no change in oxidation number. The oxidation number of hydrogen, oxygen here is positive 2 and here is negative 2 and here is still negative 2. The oxidation number of hydrogen is positive 1 here and here positive 1. The oxidation number of hydrogen here is positive 1. The oxidation number of hydrogen is positive 1 here. The oxidation number of chlorine here is negative 1. The oxidation number of chlorine here is also negative 1. So that means there's no change in oxidation numbers, or there's no transfer of electrons or movement of electrons. There's no gain of electron, there's no lose of electrons. So we are going to say not a redox reaction. Not redox reaction. Why is it not a redox reaction? We are going to say this because they are not accompanied, or it's not accompanied. It is not accompanied by change in oxidation number. By change in oxidation numbers. Full stop. That will be the reason why this reaction will not be a redox reaction. The second use of oxidation numbers is determines the species or the substance that has been oxidized or reduced. Or in other words, the oxidizing agents and also the reducing agents in a reaction. Example, number 1, we are told to study the equation below and answer the questions that follow. We are having a hydrogen gas reacting with chlorine gas, giving us hydrogen chloride gas. So we are told with the reason, state the species that undergo oxidation. What is oxidation? Increase in oxidation number is called oxidation. Reduction, decrease in oxidation number is reduction. Okay, let's check the oxidation number of hydrogen here. The oxidation number of hydrogen here is 0 because this is a combined element or elements which is in a molecular form. And we said in rule number 1, we said the oxidation number of all elements is 0, or uncombined elements, e.g. molecules, or all the atoms, we said the oxidation number is 0. So, but the oxidation number of hydrogen in this compound is positive 1. Okay, when we check chlorine, the oxidation number of chlorine is 0 because it's also an combined element or molecule, and here we're having chloride ions, so that means it's negative 1. So if you check hydrogen, its oxidation number increases from 0 to positive 1. So increase in oxidation number is oxidation. So we're going to say here hydrogen gas. We can write hydrogen along like that, and the reason we are going to say it is oxidation number, it is oxidation number, it is oxidation number increases from 0 to +1, full stop. What about reduction? We are going to have here chlorine gas. Reason? Because it is oxidation number. It is oxidation number decreases from 0 to -1. So because initially it was 0, it became -1. So next we have example 2. In example 2, we are having the following equations for some redox reaction, A and B. So to go to the question, we are told identify the reducing and the oxidizing agent in each case. We start part A, the reducing agent and its oxidizing agent. So what is reducing agent? The reducing agent is the species that undergo oxidation. So in part A, which substance undergo oxidation? Okay, in simple words, you only know whether the reaction is in between metals or in between non-metals. So if it is in between metals, that means the substance that undergo oxidation is the most reactive metal. So between zinc and magnesium, it is magnesium which is the most reactive metal. So the reducing agent will be magnesium. The reason is because we can say it is oxidation number increases from 0 to +1, I mean +2. That will be the reason. Or you can say this because it undergoes oxidation. So you can say because it undergoes oxidation. It undergoes oxidation because it is oxidation number increases from 0 to +2. Okay, what about the oxidizing agent? So the oxidizing agent is a substance that has been reduced. When you are dealing with metals, the least reactive metal is the one that has been reduced. So it will be zinc 2 ions. Reason? Because it undergoes reduction. It undergoes reduction. So what is reduction? Decrease in oxidation number. So if you check the oxidation number of zinc 2 ion here is +2. When you check it here, it is 0. So it undergoes reduction. But B, it is in between nonmetals. So nonmetals are opposite to metals. So how are we going to know the oxidizing agent and the reducing agent? So when you're dealing with nonmetals, the most reactive nonmetal will be the one that's the oxidizing agent. So the least reactive nonmetal will be the reducing agent. So in our case, bromide ions are the reducing agents. They are the reducing agents. So how are we going to know that? We can only check the oxidation number. Here the oxidation number of bromide ion is -1. But when you check here, it is 0. So what happened now? There is increase in oxidation number, and that's oxidation. So the substance that undergoes oxidation is now the reducing agent. So reason, we can say this because it undergoes oxidation. What is oxidation? Increase in oxidation number. Remember, the oxidation number of bromide ion is -1. It has increased from -1 to 0 because the oxidation number of bromine gas is 0 because this is a molecule. So the oxidation number of molecule is 0. Okay. Next, the oxidizing agent in part B, that's called chlorine gas. The reason being, it undergoes reduction. It undergoes reduction. The reason why it undergoes reduction is that its oxidation number decreases from 0 to -1. That is for part Romeo 2. Romeo 3, of the uses of oxidation numbers, we are told it helps to understand the naming of inorganic compounds. Remember, there are some elements that have good variable valences. So when naming those inorganic compounds, the use of oxidation number comes from there. So we are told, example, give the IUPAC names of the following compounds. So we have Cu2O. Here, we are having copper and oxygen. So what is the oxidation number of copper in this compound? It is 1 because oxygen oxidation number of oxygen is -2. That's why this 2 came this side. So this one, the name of this compound will be copper 1, because the oxidation number of copper in this compound is 1. And that one is written in Roman number, in capital letter. This is copper 1 oxide. So what about SO3? The oxidation number of sulfur here is 6. So when sulfur is having 6 as its valency, oxygen is having 2. When we cross multiply, we are going to get 2, 6. Then for us to write the formula, we have to simplify it. If there's a common factor, we divide by 2, 1, by 2, 3. We are going to get SO3. In doing so, the oxidation number of sulfur here is 6. So we are going to say here as sulfur 6 oxide. Sulfur 6. So that 6 is written in Roman number, sulfur 6 oxide. That will be the name of this compound. And that's the end of our video today. Thank you.